Next method is channelization. What is channelization? It is a multiple access method in which available bandwidth of the link is shared in time, frequency, or through code between different stations. See, we studied multiplexing, right? Where the shared channel will be, multiplexed. How? With respect to frequency, with respect to time, with respect to wavelength, right? The same methods are followed here. That is frequency, time, and the other one is code. Okay, so here in this, available bandwidth of the link is shared in time, frequency, or through code between different stations. What are different stations here? The stations which are sharing the common communication channel. Okay, so what we discussed in frequency FDM, that is frequency division multiplexing, the same thing is followed here. Okay, frequency division multiplexing axis, that is FDMA. Here the available bandwidth of the channel is divided into frequency bands. Okay, so whatever the bandwidth is available for a channel, it is divided into multiple frequency bands. Okay, and each channel will be assigned with each frequency band. Okay, then yeah, that is there here. Okay, each station is allocated a band to send its data. Okay, and the next one we already know, to avoid the station interferences, there is a guard band as well, right? So this guard band is also a frequency which separates the two frequency slots, right? So that the two frequency slots should not they should not interfere between each other. See, you might have seen, we listen online radio, right? FM radio, right? There are multiple stations. If you listen one station, say at 91.9, you have another station at 97.2, right? What is the difference there? There is a gap between the frequencies, right? But each at 91.9 frequency FM radio and also 97.2 frequency FM radio, they deliver the content or transmit the data at that particular slot, right? But between these two, you have a gap, right? So that gap, we call it as a guard band, okay? So that it stops interfering with each other, so that data may not be lost, okay? That is all about frequency division multiplexer. Next method we discussed is time division multiple access. In time division, what happens? Here, the bandwidth of the station shares the bandwidth of the channel in time. That means what? It is divided into number of time slots, right? So that is, each station is allocated a time slot during which the particular station must send the data, right? And also here you can see, here also we insert guard times. Okay, so with respect to this method, there is a problem, that is achieving synchronization between the different stations. That is one problem, and that can be compensated to some extent by inserting guard times. Okay, this is the second method. Third method is code division multiple access, that is CDMA. Okay, so this is a third method under channelization. So this method, CDMA, differs from frequency division multiple access because only one channel occupies entire bandwidth of the link. You can see in this image here, FDMA, what happens? Here we divide the frequency into number of slots, right? So this image depicts FDMA, and this second one depicts the TDMA, that is time division multiple access, and third one depicts CDMA. Okay, that is code division multiple access. Here you can see the bandwidth is divided with respect to, into different time slots. Here the bandwidth is divided into multiple frequencies, right? So, and CDMA differs from TDMA because all station can send data simultaneously. Here there is no time sharing. You can see here the complete one channel can send the data, and at the same time, the other stations also can send the data simultaneously. Okay, this is all about code division multiple access. Now we'll see how actually this code division multiple access works. Okay, so it is works based on the coding theory. That means what? For each channel, or for each station, which are, I mean, stations which are sharing the same channel. Okay, for such stations assigned with a code. Okay, so that we call it as a coding theory here. Okay, so each station is assigned with the code. What is that code? It is nothing but a sequence of numbers. Do you remember? It is a sequence of numbers, and we call that as a chips. Okay, so let's consider this example. This image says, say there are two stations. Okay, and these two stations are sharing the same channel here. Okay, and this station need to deliver data to another station which is present here, and this station needs to deliver the data to another station here. And as you can see in this image, both the stations sharing the same channel, right? So here, to avoid the collision, okay, to avoid the data loss, each station will be assigned with a particular code. See, this example is taken only for the explanation purpose. In reality, it will not work in this way. To make you understand the concept, this example is taken. Okay, so this station is assigned with certain color code, and this station is assigned with certain color code. Okay, so together this is transmitted over the shared channel, and at the destination the respective data will be delivered. So this station will be delivered with the same data, and this station is delivered with the data that is sent by the green code. Now, assigning the code for each station and how it is transmitted over the transmission link and how it is delivered at the other end, we'll see now. Okay, so let's consider there are three stations. Okay, sorry, four stations. 1, 2, 3, 4. Okay, four stations are there. All the stations are sharing the same communication channel. Okay, so as per code division multiple access, what is the logic followed here? Each station is assigned with the code. Say, first station is assigned with the code. Okay, code is what? It is nothing but the sequence of numbers. It is sequence of numbers, and this we call it as chips. Okay, so this is for one station, that is C1 code. Second one, C2 is the code for the second station. Third one, C3 for the third one, and C4 is the fourth one. Fourth one assigned for the fourth station. Okay, here +1 represent the data bit 1 and -1 represent the data bit 0. Okay, now see what is the sequence followed here. If for station 1, the code assigned is +1, +1, +1, +1, right? So what does it mean? +1 represents 1, right? So this follows the sequence as 1, 1, 1, 1. Okay, similarly for the second one, it is -1 means 0, right? 1, 0, 1, 0. Third one, 1, 1, 0, 0. Fourth one, 1, 0, 0, 1. Okay, in this way, the code will be assigned to the each station, those the stations which are sharing the same communication channel. Okay, now we'll see how to generate this sequence of numbers, or how to generate the chips for each station. Okay, so that is that is given by the Walsh Walsh table. Okay, the name given for this is Walsh, WALSH. Okay, Walsh table. Let's see how it works. It follows two rules. One is W1 is given as +1. Okay, W2n is equal to WN two-dimensional array this is. Okay, wn 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 and wn negate. Okay, so these are the two rules followed to generate the sequence of numbers for each station, which we call it as chips. Okay, so if there is only one station, then it is simple. You can assign the code as +1, which is nothing but +1 represent 1, right? So now if there are two stations which are sharing the communication channel, then apply this rule. Okay, so now you there are only two stations. No, you just 1 second. Yeah, you consider this value. Okay, 2n 2n. Okay, this is equal to, you need to calculate for two stations, right? So just find out what is n value, because you need n value to substitute here, right? N is equal to 2 divided by 2, 2 divided by 2, which is equal to 1, right? So just substitute that value. Here you get 1, right? Substitute here. 2 into 1 is 2 here, right? So here it is 1, it is 1, it is 1, and it is 1. Okay, now what happens? Since it is 1, you just substitute the value given here, that is +1 +1 +1, and negate this. The last value in this matrix is Wn negate, right? So +1 becomes -1. Okay, this is the code for the network where two stations are sharing the common channel. Okay, so next sequence code is this one. Okay, this is how the code is generated. Now let's consider when there are four stations which are sharing the channel. What happens then? How do you calculate it? So now 2n is equal to how much? 4. 4 stations are there, right? Now find out what is n value. That is 4 divided by 2. Answer is 2, right? So now here you have to substitute W2, 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 and W2. Okay, now you have already calculated what is W2. Just substitute that value in the first row first column, first row second column, second row first column, and second row second column. Okay, so in this way, now you can see once you substitute the value, now you can see the sequence number for first station, second station, third station, and the fourth station. Okay, now you can cross check this value with respect to the example which we discussed in this slide. What is for C1? It is +1 +1 +1 +1, right? Now you see the sequence +1 +1 +1 +1. Next one, +1 minus +1 minus, right? +1 minus +1 minus. For third one, plus plus minus minus. That is plus plus minus minus. Next, for fourth one, plus minus minus plus, right? Same thing is here. Plus minus minus plus 1. So in this way, the sequence are generated for each station which shares the common channel. Okay, now the question is, okay, if we have even number of stations, then this can be followed. What if you have odd number of stations? What if there are only 3 channels? Okay, so in that case what happens? 2n is equal to 3, right? So you will get decimal value, isn't it? Is equal to 3. When you divide 3 divided by 2, you will get some decimal value. That is not followed. If there are 3 channels, sorry, 3 stations, then it will be calculated for 4 stations itself. Okay, do remember, it will be calculated for 4 stations itself, but only 3 sequence numbers are followed. Okay, we need only 3 sequence numbers for 3 stations, right? So that's why only 3 sequence numbers are followed. If there are 7 numbers, 7 number of stations which are sharing the common channel, then what happens? It will be calculated for 8 stations. Okay, and out of which the seven codes will be considered for each station. Okay, that is all about code division multiple access. Okay, so the first one is what? Channelization. Okay, where the available bandwidth is shared in time, frequency, or through code. The first method is frequency division multiple access, right? And second one is time division multiple access, and third one is code division multiple access. In code division multiple access, it follows the code theory, where each station will be assigned with a code, and the code is nothing but sequence of numbers and also called as chips. Okay, that is how code division multiple access works. Fine.